All right, so recording's rolling. This is just for number 95, which I missed in my other recording. So here we go. Number 95 says, what is the percent change in volume of a cubic meter of concrete if the temperature is raised by, well, let's say 40 degrees or there's some temperature change? Okay, so this is also thermal expansion. I gave you the coefficient of linear thermal expansion for concrete, which did you guys notice that concrete and steel have the same coefficient of thermal expansion? You guys remember talking about this a few weeks back? That's why you can make steel reinforced concrete, because they expand and contract together because they have the same coefficient of thermal expansion. Okay, now, yeah. So what would the volume change be? Now, there's a couple ways you could approach it. You could actually use what's called the bulk modulus, which already accounts for volume change. But we're going to break this down into a linear expansion in each of 3 dimensions. Now I'm going to have a cubic meter block because that's the easiest to think in terms of. So what if I just had 1 cubic meter? Okay. So 1 meter by 1 meter by 1 meter cubic a concrete block. Okay. Well, it's going to expand, get wider. It's going to expand and get deeper. It's going to expand and get higher. Right. So it's 3 dimensions. You don't necessarily have to have a block. You could have like a giant bird statue or something, and the answer would be the same, like its volume change, but we'll stick to block. Right? And so let's look at a thermal expansion. It had one side that was originally like 1 meter, like some L naught, right? And it's going to expand like out here, call it delta L, right? Well, it's going to expand, see, that way, that way, that way. Okay. I'm thinking there's going to be a new volume compared to the old volume. So the old, well, here, new volume, wouldn't that be like, well, how about this? Okay. The expanded length to the power of 3, right? So it'd be like L naught plus delta L. So length, width, height, so you power 3. And the old volume would have just been plain L naught to the power of 3. Right? Like that. And the question is, calculate what's the percent change in volume? So see how I've set this up, volume new compared to volume old, right? Taking the ratio. So that might give me something that looks kind of like a percentage. I have to multiply by 100 at the end to turn to percent. That's the idea, right? Now, change in length. I know that the change in length is equal to original length times coefficient of thermal expansion times the temperature change. Right? So I can substitute that, and for this piece right here, let me check. That's going to go V new compared to V old is equal to, and then you, furthermore, you can factor out an L naught. So the L naught multiplied by this would be 1 plus alpha times delta T. Okay, this whole thing being cubed divided by L naught cubed, right? Is that okay so far? Do you guys see what's going to cancel out? Yeah, all the L naught stuff, right? So I was saying a meter, like a meter by meter by meter, but could be whatever crazy dimensions, whatever crazy shape, doesn't have to be a block, right? Because this is going to cancel out anyway. Is that goes away? Okay. So the ratio of the volumes, new compared to old, V new compared to V old, ends up being just this bit right here. 1 plus coefficient of thermal expansion times temperature change, all to the power of 3. Okay. Look at some numbers. And I know coefficient of thermal expansion was 12 times 10 to the negative 6. That's true for both concrete and steel. Okay. My temperature change. Now, on my paper says a 40°C temperature change. This is 1 over Kelvin. I call this Kelvin because it's a change. Okay. I have to cube this. Let's see what this would be. Throw in the middle stuff here. What is 12 times 10 to the negative 6, all times 40? So this is, and then plus 1. So this is 1.00048. Then that would be cubed, right? Because 3 dimensions. Right? So then that to the power of 3. Oops, sorry. 1.00048. 8 to the power 3. Looking at 1.00144. Okay. Now, if you're looking for, okay, so if the old volume was exactly 1 cubic meter, the new volume is 1.00144 cubic meters. Like a ratio here, right? So wouldn't that have increased by an amount equal to this minus 1? So it increased by this much as a decimal. And then as a percentage, again, how do you go from a decimal to a percent? Multiply by 100. So the percent change in volume is equal to 0.144%. Okay? Or at least that's my answer, right? So see what we're going to do. Take the ratios of the volumes, subtract 1 to get the amount changes a decimal. And then if you want the percentage change, just multiply by 100. So for me, it works out to the number right there. Yeah. There you go.